Nesterov is a kind of a mix-in. So we've seen that you can add Nesterov to standard gradient descent with momentum to get what's called like Nesterov momentum. So if we can take standard gradient descent with momentum and add Nesterov, we get Nesterov momentum. We can take atom plus Nesterov, and we get what's called natom. We could certainly take eta grad plus Nesterov, or RMS prop plus Nesterov. Anything that has momentum, you could add Nesterov to it. And the Nesterov idea really is, since we have momentum, it's just take the momentum step before you calculate the current gradient, and then calculate the current gradient after having made that step. So we're starting here. Instead of calc gradient, so instead of you're at a certain set of parameters, you calculate the gradient of those parameters, you move by the gradient, or really 1 minus beta of the gradient, and then you move by, let's say in a slightly different direction, beta times the velocity at time step t minus 1. Instead, you first move by beta times the velocity t minus 1, and then calculate the gradient, and then move by the gradient. And the key is that the gradient may be different from what it was at your initial spot. So these are the initial spots. The gradient would have been here, but now we're calculating the gradient from this new spot, and the gradient may be slightly different. Maybe it's, for instance, like this. So we'll end up at a different location than we would otherwise. And the idea is, when we're calculating the gradient, we're using sort of the latest and greatest theta that we possibly can. So since we're knowing we're going to be traveling in the beta times v sub t minus 1 direction, why don't we go ahead and do that first and then calculate the gradient. So anytime we have this momentum term, this velocity term, we can do this Nesterov. And we're viewing that as kind of a mix-in. It can be added in to any momentum algorithm.